ones, we know them well. JavaScript's fine, but TypeScript's well. We add some types and clear the air. Safer code with less to spare, yeah. TypeScript functions make it right. Type your parameters day or night. Return types, overload generics in sight. TypeScript's the future, it's shining bright. Optional and default parameters in play. Set the rules and lead the way. Rest parameters for all those args. Type safe functions, no more scars. TypeScript functions make it right. Type your parameters day or night. Return types, overload generics in sight. TypeScript's the future, it's shining bright. Our functions, short and sweet. Know your this and stay on beat. Utility types, they'll save your mind. With ReturnType, leave no bug behind. Anonymous and callbacks, oh so clean. Type them up and feel the sheen. Overload and generics, reusable fun. TypeScript is powerful for everyone. TypeScript functions make it right. Type your parameters day or night. Return types, overload generics in sight. TypeScript's the future, it's shining bright. Now practice more, get on your way. Type safe, coding's here to stay. With TypeScript functions, strong and lean, your code will be the sharpest ever seen.
So why would you want to use TypeScript? Especially, why would you want to use TypeScript with functions? Type safety is the first reason. It will allow you to define the types of parameters and return types for your function. Better documentation. What this means is that if other developers are looking at your code, your functions, your classes, or whatever, and it's easier for them to see what you've done and how to use them. Enhanced tooling. Modern IDEs, once you have a function and you've defined all of your parameters and return types, the IDEs can do really nice code completion for you, and then it's easier to use them. And reduce runtime errors. So what you want to do is try to catch the errors before they actually happen, and that will happen at compile time. So let's go ahead and do an overview here. So we're going to talk about function declarations and how they're different in TypeScript than in JavaScript. We also have function expressions and arrow functions, and these can actually simplify your code. We have advanced function types, and we'll talk about those shortly, and improve maintainability so that your code is more maintainable. Okay, so let's talk about the syntax of TypeScript functions. We're going to start off with the syntax of JavaScript functions. Name, let's return hello plus name. Okay, so we have a return type, we have input parameter and a return type. Now let's do a console.log my name Sam Smith. And we will go ahead and need to compile this. And then we'll go ahead and run this. And it says, hello, Sam Smith. But that is not what we wanted to do. We wanted to add type safety. So we want to type this, and we want to type the return. So let's go ahead and add a type here. Now we've got type safety for the input, and we're going to say string here, and that means our return is going to be a string. So here is kind of the template for TypeScript functions. Let me go ahead and put that in comments. And so it's always going to be a parameter, colon type, comma parameter, colon type, forever until you're done. and then whatever your return type is. Notice here I just have one parameter, so I say name colon string, and my return type is string. Obviously you can only have one return type. So let's go ahead and create a function called add. So we'll say A number, B number, and we're going to go ahead and return a number. So we'll say return A plus B. Okay, so that gives us type safety here for both the incoming parameters and the return type. So we'll say console.log add, and I'm going to say 1, which is perfect, right? And now I'm going to say 2. And you notice it gives me an error right here. Even before I compile it, it gives me an error. I can't compile it. It won't let me because it realizes there's a type mismatch. So let's go here, compile it, and run it. And there we go. That outputs 3. So there's a slight variation on the declarative function. Function A number, B number, and we will return a number. And in essence, this is kind of stuck. It's always going to be in the same place. But if we do this, this multiply is a function object that we can pass around to different places and use it in different places. Not just call it, but we can pass it to functions and use it in different ways. So let's return A times B. And now what we're going to do, it's going to look the exact same way when we do a console.log. We can say multiply 4, 5, just like that. And you're not going to notice the, oops, okay, so I've got to build this, compile it, run it. There you go. Okay, so you don't notice when you're using it a difference. However, like I said, this can be more independent, and you can actually pass that to a function, whereas this is kind of immobile. We also have something called an arrow function, and these are only for simple things. You wouldn't want to use this syntax for complex functions, but it helps you keep your code really small and sleek. And let's go ahead and say const subtract equals, notice I don't even have the keyword function there. So I'm going to say A number, B number, and the return type, I still need that, and that's going to be number. And now I have this thing here, this expression here, and what this means, the equal greater than, is that my function is going to follow. Okay, so do that, and go ahead and return the value. A minus B, and there we go. And this is called an arrow function, and obviously this would have to be pretty simple, otherwise it wouldn't work. A lot of people use the arrow function to keep things on a single line like this. I don't think it's a good idea, but a lot of people will do it. That's the reason a lot of people use the arrow functions, is because it's a really simple function, and so they want to make sure it fits on a single line. So here's an example of the simplest arrow function I could come up with. It's for divide, and I don't even really need the open and close curly braces if it stays on the same line. So this is an example of using this to simplify your code. So you can actually have a TypeScript function that does not specify a return type. And in this case, the return type will be inferred. Greet, name, string. And notice I'm not adding a return type here, but I'm going to go ahead and return a string. But I'm going to go ahead and return a string. Let's see. I don't know if you remember string literals from when we talked about them in JavaScript, but when you start an expression with this backtick and end it with a backtick, I know it looks like a single quote, but it's not. What that means is treat this like a string, everything except if we do a dollar, open paren, and then variable name, close paren, that's the same as put the contents of that variable into this. It's easier to understand and read, and it's more efficient than just simply concatenating things with the plus operator. So I can say console.log greet Quasimodo, and we can go ahead and compile that and run it. Hello, Quasimodo. Okay. So there might be times when you want a parameter for a function to be optional. And this is going to help you when maybe you have some overloading you want to do. You can actually create multiple functions to do the overloading, and that's great. But you can also sometimes use the same function and have some of the parameters to be optional. So as you can see, I can just say greet. And of course, if I don't have a parameter there, it's going to complain. And now let's compile this, compile and run this. Compile it, run it, and it just says Rick. Okay. So what we're going to do right now is we're going to see if we can figure out a way to make these parameters optional. And as a matter of fact, there is a way. If you just put a question mark at the end of the parameter name, then it is optional. You see, I've done that, and if I recompile and rerun this, you won't notice any different. There we go, it still says Rick. But I can also do this, and it's okay. I didn't give it any parameters. It is, before it was expecting one and requiring one. Now it's saying, well, if you give me one, I'll use it. Otherwise, it's okay. So let's go ahead and compile and run this. And we see undefined because name is undefined since I didn't pass it in. So inside of here, inside of the function, I can say if type of name equals undefined, else. And so here I can just say console.log and say console.log name not specified. So let's go ahead and compile and run this now. Compile, run, and it says name not specified. And I can go back and add my name, compile and run it. Okay, and there it still works fine. All I've said is that you don't have to give me this parameter if you don't want to. If you don't, I'll know what to do with it. If you do, here again, I'll know what to do with it. You can write a lot of functions that can be used in many different ways without having to write these separate overloaded functions. We can also set some of the default values for input parameters, such as name or say hello. So I'm going to use a ternary operator here. Console.log, and we're going to say hello, question, hello, for that. I'm going, this is not actually necessary, but I still am going to do it. And that way, if this is true, it will say hello and then the name. Otherwise, it will just say the name. Okay. You notice I get an error here, and that error says, well, you have a second parameter that you did not specify, and it's expecting that. But what if I'm almost always going to want to say hello? And so it's really kind of extra work for me to go through and say true all the time. And maybe 1 out of 100 cases I'll say false. So what I can do is give it a default value. And that way, unless I specify what it is, it will say hello. So let me go, and notice the error goes way down here. So let me go ahead and compile this. And run it. And it says hello Rick. Unless I say false here, because I don't want it to say hello. I just want the name to be output. So you can have a function that might most of the time do one thing and only in rare situations do another thing, and have some sort of a default parameter that you don't need to specify very often that will give you an option for a different behavior. There are times when you might need a function that takes an unknown number of arguments. For instance, it might take 1, 3, 5, depending on the situation. And a good example of this is if you've ever done any C programming, the printf argument. So printf takes a string with the formatting specifications, but then you can have any number of arguments after that get printed out. And that's exactly what we're trying to do here. We're trying to make sure that we are able to create functions that have an unknown number of parameters. So obviously this is an error because there's no such thing as type or return type there. Here's the format of it. Obviously the keyword function, the function name, and then we put these 3 dots in front of it. And that says this is going to be a rest parameter. We give the rest parameter a name, and then we specify the types. And it's always going to be an array, because the array is going to contain whatever the list of parameters that you got in. Put this into source code comments real quick, because otherwise I won't be able to compile and run this. Okay, so there's my new function. I called it show all. ... means it's a rest parameter. Numbers is the name of the rest parameter, and it's going to be an array of numbers. Okay. This function isn't going to return anything, not that that makes any difference for what we're doing right now. Okay, so here I have a for loop that's going to count from 0 up to the length of the number list, the number array, and output the numbers. And to call this is very easy. It'll be your parameters all separated by commas. And if I compile this and run it, you'll just see it outputs a list of 5 numbers. Could be really anything. I could do 6, 7, or whatever. So this is a for loop. And I could also use the alternative of a for each. Straighten up that. So we're just going to do numbers, which is the name, dot for each, and I can name this anything I want, element, I, value, whatever I want to name it, console.log, value or element, whatever I named it. The nice thing about this is you don't have to worry about the type. It will do a discovery. The for each does a discovery and figures out what type it's outputting. So this actually is pretty nice. Let me go ahead and compile and run this. So counts from 1 to 7. As a special note, you can combine rest parameters with other types of parameters. So I can have something here called my value number, and then I have my rest parameter. The only rule is that your rest parameter must come at the end of your function. Let's talk about overloaded functions. Most of you have probably had some experience with an object-oriented language such as Java or C# when you overloaded functions. It's a good bit different in TypeScript. So to define an overloaded function, you provide multiple function signatures before the function implementation. Then you write a single function implementation that handles all of the possible cases. So I have an example I've created here. I'm just going to grab that and run through it. Okay, so here I have this function called combine, and this is a function signature. It's not a full function. So it takes two numbers and returns a number. This takes two strings and returns a string. And this is actually the implementation. Notice it's using any here and any here and any here because it can either be a string or a number for all of these. Okay, so what you do inside this combine function is first you look at what you've got. If I have two numbers, I go and return those added together. If I have two strings, I go and return those two added together. Otherwise, if I don't get two numbers or two strings, I throw an exception letting the user know that something went wrong. Okay, so let's go ahead and use these now. I've got a couple of console.logs that use combine. And let me go ahead and save that. Compile it. Run it. And so it's able to use both of those functions, two numbers and two strings. So TypeScript also allows you to define overloads that return different types. Based on the parameter types. This can be useful when the output type depends on the input type. So I have an example here. I'll paste it in. We'll trace it through. Okay, so I have this function called getItem. Takes a number, returns a string, takes a string, returns a number, or I can use an any type, and that way you can take a number or a string and return an any. Okay, so here I'm returning whatever the type is based on what I got in. And let me go ahead and put in a couple of examples that use this. Compile and run this. And there we go. So anonymous functions are one of the things JavaScript and TypeScript are famous for. They don't have names, that's one thing, so they're not going to pollute the global space. They're often used as arguments to other functions. For instance, you might have this anonymous function and I'm going to pass it into another function, and that way that other function will know what to do. It will call this anonymous function without a name that you passed in. So an anonymous function is a function that does not have a name, and these are sometimes used in scenarios where the function is not needed anywhere else in the code. So these are very convenient to use as callbacks or when a function is assigned to a variable. So the basic syntax is something like this. Some sort of variable is going to equal this anonymous function, and we have however many parameters, however many types, and a return type, then some sort of a function body. And let me go ahead and comment this out. So here's a real example now. Here's the real anonymous function example that will compile. And I have this greet function, and we've been using a greet function for a while, but this is an anonymous version of it. So it takes a name as a string, returns a string, and in order to use it, you simply use this greet object here that you created, and you say greet Alice. It looks like a regular declared function down here in the console.log, except for there's nothing in the global space for that function. It's also convenient if you need to pass that function around to other functions. So here's a more complex example. I have this So this is a declared function process array, but it needs a callback. Okay, it needs a callback so it can call this num number. And here again, you might have different times for when different callbacks are necessary. It just goes ahead and maps to callback. And now in order to use it, we create this anonymous function and use it down here. And so it's going to take this array here and iterate through it and go ahead and output the array doubled. Here you go. The last thing we're going to talk about for this functions section are arrow functions. So in short, arrow functions are going to help you create really small code that is easy to read and easy to use and easy to understand, and it will also help keep your code quite a bit cleaner. So these arrow functions are shorter syntax. We use the equal greater than symbol, which we also call the arrow operator. So here's the general syntax of it. So you're going to have some sort of a function name, and then here's your typical parameter list, return type, and we have this arrow operator here, and then the function body. That's actually not going to compile just because it's just an example. But now here might be the most simple arrow function I could create. You see how it actually does something. It's on a single line, and it also does not pollute the global namespace because there's no name for the function. Obviously you're going to assign it to this object here, but notice we have the parameter list, the return type, and then we have the arrow operator, and then whatever the function is going to do. So let's go ahead and use that function. It's also pretty easy to do. I'm going to compile this and run it. And there we go, it outputs a 5, which is exactly what you'd expect. Here's another similar one. Just squares a number. Let me call that real quick. Compile it. Run this. Okay. And the last example is maybe a little bit more complex, but in general you're not going to find that arrow functions are complex at all. So here I have this array of numbers, and all this arrow function does is multiply by 2. So we're going to double everything in this list. It's going to map each number to this operation. Use of this, save it, and run it. There we go. And so that's it for arrow functions and for TypeScript functions.